Hi there, this is video C16. It is a review of what we've done so far. So it's going to cover fundamental counting principle and permutations. So remember, for the most part, any question that you can do as a permutation, you can also do as a fundamental counting principle. The only exception to that would be when you have elements that are the same. So you have a bunch of letters like calluses. You've got lots of I'm having a brain fart. You got lots of S's in that word. Or Canada, because it's got some duplicates. But if the elements that you're arranging are all different, then you can use permutation or fundamental counting principle, whichever one makes you happy. And you can remember with permutation, you can use a formula or you can use your calculator. Anyway, let's get started. Actually, I lie. What I prefer you to do is turn off the video, do the questions, give them a shot, and then you can check your answer key. Or you could, that's what I want. I guess you could turn the video back on if you're having problems. Okay. So, okay, I'm going to trust your back that you actually did turn off, give it a shot. In how many ways can you arrange the letters of the word throw? So, here's what I would see. First of all, that word. Okay, arrange definitely screams permutation. I'm not that creative when I'm making up questions that I'm going to use this thesauruses to find new ones. So arrange probably says that's what we're going to have. So I'm going to show you two different ways. So for arrange permutation, I have 1, 2, 3, 4 letters, and I'm arranging all 4. And I can use my handy calculator and go 4. And this one I have to do shift and 4 and equals. That's 24. Okay, you can also use formula, but I have my calculator at this exact moment. I don't remember the formula. Or you could also just go 1, 2, 3, 4. You can imagine that those letters are written on little pieces of paper because you can't, there's no repetition involved. So I've got 4 choices and then I used up 1 letter. So it's 3 choices, 2 choices, 1 choice. And if you go 4 times 3 is 12, times 2 is 24, times 1 is 24. You get the same answer. So this permutation is fundamental counting principle. And they're the same. So I should write equals 24. They're exactly the same answer, and I don't care which one you use. You get the same answer. Okay, next one. Combination lock as a dial bearing the numbers 1 through 14. How many 3-number combinations are possible, assuming that a combination may not have repeated numbers? This isn't really arranging stuff. I don't see it that way. This to me says my first number, second number, my third number. Yeah. It's got numbers 1 through 14. So to start, there's 14 choices. Now, it says you can't repeat. So once I've used number, let's say I used 10 first, it's out of the running. So then it's going to be 13 and 12. 14 times 12. 2,184 ways. I guess that could be a permutation. It would be 14 numbers arranged in 3. Let's just check. 14. Yeah. Same answer. It's all how it appeals to you. For me, the two of them, I will use them interchangeably. If I can't, this is my easy one, but if it doesn't make sense right away, fundamental accounting principle will answer all of them. All right. Next one. Oh, I should point out, and it'll come back later. When we're done this, we're going to talk about something called combinations. And a combination lock is evil. It should be called a permutation lock because the order that you choose your numbers does matter. Just saying. And that's also why combinations was in quotation marks. Okay, on to the next question. Excuse me. Diogenes has 6 pet ferrets. He has the following 4 gifts to distribute to the ferrets: a ribbon, a blue bow, a diamond-studded collar, and a bottle of ferret shampoo. In how many ways can the gifts be distributed, assuming that he has only one of each gift? Okay, so right there, that tells you you're not using a repeat pattern, and no ferret will get more than 1 gift. There and here. Yeah. I put that question in simply because it doesn't say, hey, there's no repeats. It does it in a different way. So the question got 2 numbers. How many, what are you going to do with them? Or how is this going to work? Now, am I going to make 6 blanks because there's 6 ferrets? Or am I going to make 4 blanks because there's 4 gifts? You know what? Let's try it each way and see what happens. Let's 6 was first. So 1, 2, 3, 4, 5, 6. Yeah. So this is first ferret, second ferret, third ferret, fourth ferret. Get that. So when I go to my first ferret, there are 4 gifts that he can give. And then we go to the next ferret. There's 3, and then there's 2, and there's 1. Doesn't really make much sense, does it? Right? Because when we're doing this, there should be enough numbers, enough things to fill in all the blanks. So this doesn't make sense. Or let's try it the other way. 1, 2, 3, 4. So make this pink ribbon, the blue bow, diamond collar, and ferret shampoo. Let's do it the other way. When it goes to give out the pink ribbon, how many ferrets is going to give it to? There was 6 in total. So there we go. Okay. So he gives that to his very favorite ferret, and then he's going to have how many left? Right, 5 gifts. Sorry, 5 ferrets to give the gift to. And then he will have 4 ferrets. And he will have 3 ferrets. So 6 times 5 times 4 times 3 is 360. I guess you could think of that in terms of you have 6 ferrets and you need to arrange 4 of them in a row. Those are the 4 that are going to get the gifts. But I hope you can see that that one's not going to work. Okay, I'm excited. I had to pause there because I thought of a different way to do the question. I didn't want to put it in the video unless I knew for sure it was going to work. So here's a different way you can think of it. I just finished saying that there were no repeats, but you can think of it in terms of this question having repeats. So what I did, I think you can figure it out. There's these are my gifts: pink bow, sorry, pink ribbon, blue bow, diamond collar, shampoo, and then nothing and nothing, right? Because there's 6 ferrets, so there's going to be 2 of them that don't get anything. So I use that. So then you can think of this as one where the elements are not all different. So 1, 2, 3, 4, 5, 6, factorial. And then a 2 factorial on the bottom for the ends. And surprise, oops, can't see that, but oh, 6 factorial divided by 2 factorial is 360. Ta-da! I just discovered that, figured that out myself right now. So there's a lot of different ways to do these questions. Okay, next one. There are 4 newly hired employees at the Hypergomer Corporation. Each new employee will be assigned to an office. There are 8 offices to choose from. How many outcomes are possible, assuming it is possible for more than one employee to be assigned to the same office? Okay. So I'm going to try and keep it simple. How many blanks do we need? I would say 4. Because each person gets to decide on their office. So the first guy comes up and he has how many offices? Exactly. There are 8 possible. So now the question becomes, do we count down or something else? Or does it stay at 8? Well, this question I put in here because it's cool. Because you could have more than one employee in the same office, which means when the second guy goes to get his office or her office, she could say, I want to be in his office. So it could be in the same one. So 8. The same reasoning all the way through. And that's just because of this phrase. Okay. If it says how many outcomes are possible, assuming that they don't share offices, then we'll go 8, 7, 6, 5. But because they can share or be assigned to the same one, it's gonna look like that. So we got 4,096. All right. So that one was definitely a fundamental counting principle. Not sure if you could. Yeah, I don't want to overthink this. I don't think. Hold on. I'm going to pause and I'll get back to you. Nope, I don't think we can do that using the repeating formula like we did for this question. Sometimes I just get excited and overthink stuff, so we're not going to go there. Ooh, the bookkeeper. In how many ways can all the letters of the word bookkeeper be arranged? Okay, the moment you see this, a little too far there. You know it's going to have that repetition formula. So that is the n factorial over r factorial t factorial. Apparently I don't know my letters today. So total choices and repeats. However, this one got a little fussy. And I've also given you the answers for it. The arrangement must start with a beat. So this is how you do these. And I would suggest we do 1. Do 1, then you should pause the video. Once you've seen how it's done, you should be able to do the rest of them. So weirdly enough, I'm only going to draw 2 blanks because there's kind of 2 decisions that have to be made. First one is it's supposed to start with a B. And there's 1 B in there. Now, the second part is you need to arrange everything else. That's this part. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 letters left. Better count. Okay. Now our factorials, we've got 2 O's. And we've got 1, 2, 2 K's. And we've got 1, 2, 3 E's. And B and R. So let's see. I'll hope it in. What if I put it over there? Then we can see it. So 9 factorial divided by 2 factorial divided by 2 factorial divided by 3 factorial. Whoops. That's not going to work. Okay, try that again. 2 factorial divided by 2 factorial divided by 3 factorial. And there we go. 120. So this is the B in this part. Rest of the letters. Okay. Got it? Try the next one. You're gonna do it the same way. We got to start with an E. And then this part is going to be the rest. I don't want to write rest underneath because then I'm not going to have room to put my stuff in there. All right. So in our word bookkeeper, there are 1, 2, 3 E's. And if we use 1 up, I know that's going to leave me with 9 left over, just like here. So that's going to be 9 factorial. Now our bottom part, I think, is going to change. So only 1 B. There's still 2 O's, so that's going to be 2 factorial. There's still 2 K's. That's going to be 2 factorial. But now, see, before we had 3 at the end. And that was for the E's. But this time we've already used up 1 of them. So we've only got 2 left. So I'm hoping this is going to be messy. So this was the O's, this was the K's, and that was the E's. Now let's try that 9 factorial. Oopsies. You need to remember the 3 times 9. Start over. 3 times factorial divided by 2 factorial divided by 2 factorial divided by 2 factorial, and that's not the same answer that we got. Okay. Well, notice I just cheated. I divided by 3. So that needs to be a 1. So this is just taking our first letter out. And I guess because we're not really arranging it, then it's going to be, the rest of it works. Sorry about that. Sometimes I screw up, and that is the reason that you need to make sure you check your answers. And I just guessed because when I put that 3 there, I wasn't 100% sure. And that's sometimes the nice part about knowing the answers is you can go back and go, oh, okay, well, I just took 1 letter out and then was just rearranging the rest of them. All right, see how we can do on the other ones. The arrangements must start with a K and end with an O. There's going to be a K. There's going to be my O. Now, A's on this, I'm going to put a 1 there and a 1 there because we're just taking one out of the mix. Now, what goes in the middle? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I knew there was 10 numbers. I used up 2. So that's going to leave me 8 left over. Right, so this is my leftovers. Now, I don't have to worry about the B. There are 2 O's, but I already used one of them. So I don't have to worry about that for repeats. There are 2 K's. Let me do it here. Okay, so the B doesn't repeat, don't have to care. I've already used up. Let's do this. My 1 O here, so these ones don't repeat. Okay, because there's only 1 left to range. Same argument with the K's. They use the 1 to go there, so there is no repeats here. So then I should just have 3 factorial on the bottom. And yay, 720. So that one worked out. And that's why it's good to do like a bunch of questions, because once I realized my mistake here, I knew how I was going to prepare. All right. The vowels must be all together. I really got to think about that. So I'm going to look at this. I'm going to put this on a different sheet of paper. That's what I'm going to do. Just, you know, in my heart right now, I really want to turn off the video, figure it out myself, and then come back. But that's not really teaching you the process. So let's give it a shot. Sometimes we make mistakes. So this is 5. All right. So vowels together. So I'm going to try it. I'm just going to use, we're going to put all the vowels together. So let's highlight them. This is my plan. Stay with me. I'm going to arrange this word. Where this stands for all the vowels. And then we'll worry about arranging them. Okay. So consonant, there's my 2 Ks, my P, my R, and this stands is a stand-in right now for my vowels. This is kind of like those questions where Billy and Bob have to stand beside each other in a line. So there's 1, 2, 3, 4, 5, 6 things I have to arrange. And I'm going to have to deal with the 2 Ks. So that's going to give me a 2 factorial down there. So, and then we're going to have to multiply by, this is the part. So this is all letters. Oops. Put it back so we can see. This part is the vowels. And there are 1, 2, 3, 4, 5. So factorial. I'm arranging just the highlighted part. So O, O, E, E, E. So there's my 5. And then there's 2 factorial for the O's and 3 factorial for the E's. Now I'm hoping, really hoping that when we do all this, it's gonna work. Let's 6 factorial by 2 factorial times 5 factorial divided by 2 factorial divided by 3. Okay. Deep breath equals 3,600 and yes. Just for mathy bits, if you wanted to go 6 times 5 and then divide at the end, it doesn't matter. All right, so there we go. And put a little note. Okay. So now, I think you can do this one. There should be enough room to do it there. Now that I'm feeling confident. The vowels must be together and the consonants must be all together. Okay. No, I'm not. I want to do it on a piece of paper. Okay, so this is really just going to be building on what we did. So we're going to arrange our vowels. Let's start with that. And I kind of already know 1, 2, 3, 4, 5, 5 vowels. And there's 2 O's, 2 factorial, and there's 3 E's, 3 factorial, times. Now for my consonants, there are 1, 2, 3, 4, 5, 5 factorial, and the only repeats we have are those 2 K's. Wait. Oh, goodness. Much better if you could actually see what I was writing. And then. Now, I'm 90% sure I need this last part, but if my answer ends up being too big, I'll know why. I'm going to multiply my final answer by 2. Now, the reason for that, well, there's 2 ways I can explain it. Because it could be vowels and then consonants, so all vowels and all the consonants, or it could be all the consonants and then all the vowels. So there's 2 different ways that we can arrange those chunks once we figure them out. So let's see how we can do this. 5 factorial divided by 2 factorial, 3 factorial times 5 factorial divided by 2 factorial times 2. You get 1,200. That, I'm pretty sure, is what the answer is supposed to be. Okay, sorry. There we go. That this part is a vowel consonant, consonant vowel. You could also have done it as 2 different cases, one where the vowels are first and one where the consonants are first, and then add them together. But that would be exactly like multiplying it through by 2. All right, let's see. The 2 middle letters must be a B and an R. So there's another one where I really want. I should admit to you, I really want to turn this off and try it myself. But so we're gonna have some letters, and then the B and the R in the middle, and then some more letters. I'm gonna turn it off because sorry, I'm going to pause it. I don't want to take you down the wrong lane. Okay, I'm back. I was way overthinking that question. Here's the scoop. Even forget my drawing here. So whether we put the BR in the middle or we put it at the very start, it doesn't matter because you're just going to rearrange all the other letters. So my brain is it's going to be BR. There's only one way we can do that. And then this is the rest of the letters. So if we do that, there are 10 letters in the word bookkeeper, and I've used the B and the R, so it gives me factorial. And then I need to worry about the O's, so it's 2 factorial, and the K's, 2 factorial, and the 3 E's, which is 3 factorial. So 8 factorial divided by 2 factorial divided by 2 factorial divided by 3 factorial gives me 1680. Now, not big enough, is it? Well, it says the 2 middle letters have to be B and R, but they also could be R and B. It doesn't say they had to be in that order. So there's one set this way, and there's another set that has the R and B in there. So we're just going to take our answer and then multiply it by 2. And then we get that one. Not the best question. And I did look to see if I could find a better explanation for it than the one I just did, but there we go. But that is the way I would look at it. I was trying to do numbers in front and behind it. Yeah, all you would do is you'd figure out the way to arrange all the other letters, and then you would just put the B and R in the middle like they're supposed to. All right, that is the last question. Have a lovely day.